What is software development principles? It is a number of specific rules and recommendations which engineers need to be followed during program implementation if they want to write beautiful, understandable and maintainable code. There is no magic wand by which you can transform a mix of variables, classes, and functions into the ideal code, but there are some tips and hints which can help the engineer to determine if he's doing things right. Principles deals with process and the final product. Principles are not enough to drive software development because it's abstract and general. Principles form the basis of methods, techniques, methodologies and tools. Software engineers apply the principles of software engineering to the design, development, maintenance, testing, and evaluation of the software. These principles facilitate to develop software in such a manner that it possesses all the qualities like efficiency, functionality, adaptability, maintainability, and usability. There are 7 general and important principles that apply throughout the software development process. These are rigor and formality, separation of concerns, modularity, abstraction, anticipation of change, generality and incrementality. Rigor and formality. Software development is a creative activity. In any creative process there is an inherent tendency to be neither precise nor accurate but rather to follow the inspiration of the moment in an unstructured manner. Rigor, defined as precision and exactness, on the other hand, is a necessary complement to creativity in every engineering activity. It is only through a rigorous approach that we can repeatedly produce reliable products, control their costs, and increase our confidence in their reliability. Rigor does not need to constrain creativity. Rather, it can be used as a tool to enhance creativity. The highest degree of rigor is what we call formality. Thus, formality is a stronger requirement than rigor. It requires the software process to be driven and evaluated by mathematical laws. Of course, formality implies rigor, but the converse is not true. One can be rigorous and precise even in an informal setting. Separation of concern is a recognition of the need for human beings to work within a limited context. As the human mind is limited to dealing with approximately 7 units of data at a time. Trying to do too many things at the same time often leads to mistakes. Separation of concern supports parallelization of efforts and separation of responsibilities. There are various ways in which concerns may be separated. First, one can separate them in time, qualities, and different views of the software to be analyzed separately. Modularity. A complex system may be divided into simpler pieces called modules. A system that is composed of modules is called modular. Decomposability of a system is based on dividing the original problem top-down into subproblems. Composability of a system is based on starting bottom-up from elementary components and combining them in steps towards finished product. To achieve modular composability, decomposability, understandability, and modifiability, the software engineer must design the modules with the goal of high cohesion and low coupling. Abstraction is a fundamental technique for understanding and analyzing complex problems. In applying abstraction, we identify the important aspects of a phenomenon and ignore its details. Thus, abstraction is a special case of separation of concerns, wherein we separate the concern of the important aspects from the concern of the less important details. Anticipation of change. Ability to support software evolution requires anticipating potential future changes. It is the basis for software evolvability. It affects the management of the software process. It may focus attention more on software products than on software process. Generality focus on the discovery of a more general problem. While solving a problem, try to discover if it is an instance of a more general problem whose solution can be reused in other cases. Carefully balance generality against performance and cost. Sometimes a general problem is easier to solve than a special case. And last software engineering principle is incrementality. Incrementality characterizes a process that proceeds in a stepwise fashion. An incremental software development process simplifies verification. If you develop software by adding small increments of functionality, then, for verification, you only need to deal with the added portion. If there are any errors detected, then they are already partly isolated, so they are much easier to correct. A carefully planned incremental development process can also ease the handling of changes in requirements. To do this, the planning must identify use cases that are most likely to be changed and put them towards the end of the development process.